One of the most important mathematical constructs in geometry is a straight line. Now, we'll talk about the concept of straight in a minute. But what is a line? How do we describe a line? So in maths, a line is a continuous graph, okay? Keeps going forever in both directions. What most people, non-mathematicians, call a line is actually called a line segment, a part of a line between a start and an end point. So let's have a look at some lines. Here we have a collection of coloured line segments. Now, how would we describe them? Now, we could talk about their length, but that's not something I want to consider today. So we can't talk about the length or the colour. What would we use to describe them, to discriminate against both of them? So, blue. How would you describe the blue line? Blue line? I reckon a word beginning with V? Yes, it's vertical. What about the red line? I reckon the red line begins with H. Horizontal. Okay, after horizon. So that leaves the yellow, the black, and the green. Now, they're not horizontal and they're not vertical. So what are they? I think, let's see, yellow, black, and green. So maybe beginning with D, I reckon. Diagonal. Right. Now, anything else? Looking at the diagonal lines, is there anything else we could say? Is there something that makes yellow and black similar and green different? Well, I think we could say yellow and black are sloping upwards if you go left to right, and green is sloping downwards if you go left to right. But apart from that, there's not much else you can say, is there? So if we look at what we've used to describe it, vertical, horizontal, diagonal, sloping up, sloping downwards. So all of these are some measure of slope. So the best way we can describe these line segments is by their slope. Now, mathematics is all about measuring. Geometry, measuring lengths, measuring angles. And if the only descriptor we've got for lines, straight lines, so far as slope, we're a bit stuck, really. Because how would we describe them? That one's a bit slopier than the other one. We could use words steeper. That's more steep. That's less steep. But mathematics revolves around numbers and letters. And we need some sort of number to be able to give us an indication of how slopey or how steep a line is. And to do that, we need to give these lines a context. And that context is the Cartesian grid. Now, with a context, we are able to describe this line in 3 different ways now. Okay, can you think of the 3 different ways we could describe it? Well, first off, how is the line interacting with the Cartesian grid itself? So the Cartesian grid is defined by an x-axis and a y-axis. In fact, the x-axis label's fallen off, so I'll stick it there. So that's the x-axis, the horizontal axis, and then the y-axis is the vertical axis. So how does the red line segment interact with it? Well, the first thing it does is it intersects the y-axis, doesn't it? So we can see that here. It intersects the y-axis at 3. And then if it intersects the y-axis, does it intersect the x-axis? Well, yeah, it intersects the x-axis at -3. So we have 2 axis interceptions that allow us to describe that line now. We could also, if you can remember how to do the coordinates, if we call that A and that B, then the coordinate of A is, what do you think it is? So x comes before y, so the x value of A is 0. So stick a 0 there, 0 there, and the y value is obviously 3, yeah, because there's the y-axis, and this is 3. So we can put a 3 there. And then for B, we have the x-axis. So here's the x-axis, so it cuts the x-axis, or intersects it at -3. So that's -3. And then it intercepts the y-axis at, so here's B, and where's it intercept the y-axis? So where's it intercept this line? So it's 0, okay? So there you go. So we've already been able to describe this straight line segment as intercepting the x-axis and the y-axis, and they are the x and y-axis or the coordinates for interception. Now, when we were talking a bit earlier, before we put this Cartesian grid, we talked about the only real way we could describe the line segments was by slope. Okay, now when we're talking about slope, you often get in your head the idea of, well, you're walking up something. If you walk up something that's steep, it's more tiring than if it's less steep. And you can also walk down slope, can't you? And it's easier to walk down something that is less steep than it is very steep, because if you're walking down something very steep, it'll make you run faster, and if it becomes vertical, it's a cliff, and you fall off and splat yourself. So, inherent in that concept of slope is the idea of travelling, yeah? If you're standing at a certain point, so if you're standing at, say, point A, if you imagine the red line as a slope, although the slope itself is steep, if you're standing at point A, there's no slope because you're not moving. You have to travel. So inherent in the idea in mathematics of a slope is travelling between 2 points. And it's that travel that you do between 2 points that gives you the gradient. Okay? So, travelling between here, between B and A, so between here and here, we can see we're going uphill. Now, we always go from left to right in Cartesian grids anyway, okay? So we're going uphill. But how could we measure that? Now, some of you may think, you know what? I think we could put the x-axis in, okay, along here, and then we'd have an angle. And we could measure it as an angle. And that is one way. There's a system called polar coordinates that do that. But we're not going to look at them today. We're going to look at the standard method for measuring slope. Now, we talked about to measure slope, you have to travel. So one way to get from B to A is to go along the slope. But can you think of another way you could get from B to A? Or you could think about traveling from B to A. Well, you could travel horizontally, and then you could travel vertically. And a horizontal is an x-axis, and a vertical is a y-axis. So we could say going from here to here is the same, ultimately, as going from here to there, because you end up starting up at the same place. And that's how we do measure slope, okay? And we use a posh word for slope. It begins with G, and you might have seen it on some road signs. We use the name gradient. Okay, so gradient is the posh word for slope, or for steepness of slope. Steepness of slope. All right. Now, we've talked about separating out the travelling horizontally and the travelling vertically. So the formula for working out a gradient is the difference in height. So the difference in the vertical, okay, over the difference in the length, or the horizontal, or sometimes it's called the travel, what you've travelled horizontally, okay? And that's how we work gradient out. Now, because we've got a Cartesian grid, we have 2 points, okay? And what we actually do is gradient is defined as difference in y over the difference in x, okay, between 2 points. Now, D stands for difference, okay? If you y and x, if you get confused, remember y rhymes with sky, and sky always goes on the top. So that's one way to remember it, dy over dx. So if we have 2 points, we have the y value for b. It's a difference, so take away the y value for a over the x value for b over the x value for a. Okay. Now, you can do it the other way around. It doesn't matter as long as the numerator and the denominator are both the same way around. So it could be ya take away yb over xa take away xb. But as long as they're the right way, both the same way around, that works. So in this case, okay, let's see if we can work out the gradient. So the gradient dy dx equals, well, what's the y coordinate for b? So if we go up here, here's b, that's the x component of the coordinate, that's the y, so it's 0. So we have 0 take away. What's the y component of a? So here's a, the y component is 3. So that's 0 take away 3 over, we need the x component of b. So here's b, the x component is negative 3. So, and then we have the x component of b. So here's b, here's the x, that's negative 3. So that goes there. Take away or subtract the x component of a. So here's a, the x component is 0. Let's take away 0. Okay, and that gives us dy dx equals negative 3 over negative 3, which equals 1. So this line segment has a gradient of positive 1. Now what that means is that for every 1 we go along in the x-axis from left to right, we go up 1. And we can see that by drawing lots of right angle triangles all over here. Okay, using the line segment as the hypotenuse. So the one we've just done is this one. So we've gone 1, 2, 3 along and 1, 2, 3 up. So for every 3 we go along, we go up 3, which is the same as for every 1 we go along, we go up 1. Or for every 2 we go along, we go up 2. Or for every 9 we go along, we go up 9. And that's the definition of a straight line. The definition of a straight line is a line that has a constant gradient. So no matter which 2 points you pick, so we could have points C, D, E, F, G. The gradient between any of those 2 points will always be 1, which means that the difference between the y components of those 2 points divided by the difference of the x components will always be 1. Okay? Now 1 is a very special gradient. It's a line that rises up at 45 degrees if the x and y axes are the same, okay, the same scales. Now, what about a sloping downwards line? What do we think about that? Well, let's have a look. So here we have a line segment that slopes downwards, okay, from left to right. You can see the slope is down. Now, on the last slide, we said we could define the slope, the steepness of the slope, as a posh word called the gradient. And we define the gradient as dy over dx. The difference between y and over the difference between x between 2 points. So let's pick 2 points. Okay, so we'll pick one here. Let's use our green pen. Whoops, we'll pick one here, we'll call it A, and then we'll pick a nice easy one there, and we'll call it B. So these are our 2 points we're going to look at. So let's work out what the coordinates of them are. So what do you think A is? Well, let's see, A is the x component comes first, so that's -4, and the y component comes second, so that's 0. Okay, and then B, we have the x component of b is 0 and the y component is negative 2. So if we're going to use dy dx, okay, so dy dx equals the difference between the y's. So the difference, so the y component of a, take away the y component of b, over the x component of a, take away the x component of b. Sorry, it should be b. Okay, so that's the difference between them on the x and the difference between on the y on the numerator. Okay, so let's have a look what they are. So a, the y component of a is 0. The y component of b is negative 2 over the x component of a is negative 4 and the x component of b is 0. So that comes to, so 0, subtract negative 2, gives you positive 2 over negative 4, take away 0, negative 4, and that gives you negative a half. So the gradient of this line is negative a half. And that gives us a very important point, which is that any line that slopes upwards is, or slopes upwards diagonally, is a positive gradient, and any line that slopes downwards diagonally from left to right is a negative gradient. So that's always something to check. So what does it actually mean? Well, what it means is that for every 1 we go down, because we're dropping down now because it's negative, we go along 2. Okay, and we can see that quite easily, can't we? So we do blue again, we can see, let's pick this point. So for every 1 we go down, which is going negative direction, yeah, that being the negative direction, we go along 2. So negative 1 over 2 is where we get negative half. Equally, we could do a bigger one. We could say for every, what could we do? 3 we go down. Okay, so we go along 6. Yeah, so for every 3 we go down, go along 6. Negative 3 divided by 6 is negative a half. So that's the important thing to remember about lines. Horizontal lines that slope upwards, positive gradients. Lines that slope downwards, negative gradients. Okay, now the steeper the line, the bigger the number. Okay, and let's see why that's the case. So here we have 4 different coloured straight lines, each of which has a different slope, steepness, or as we now know, posh word, gradient. So we can tell the yellow has the lowest gradient, followed by the red, followed by the blue, and the green has the steepest gradient. So let's see how that's affected using the formula. So we know the formula is gradient formula is calculated by dy over dx, difference in y over the difference in x between 2 points. And I've made all the lines share 1 point, A. So let's get the coordinate of A. So we should know that's negative 3 on the x-axis and negative 3 on the y-axis. And then for yellow, okay, we have, should we do it on yellow? It'll be funky. So for yellow, we have B. B should be 3, 0. Then C is on the red line. So C is 3, 3. D is blue. So D is 2 on the x-axis, 7 on the y-axis. And then green, that's a G, not a 6, is 0 on the x-axis and 9 on the y-axis. Okay, so let's try and work out the gradients of these using the formula and the points we've got. So first off, let's work out the slope of line AB. Okay, so the gradient of AB is, so it's difference in y, so A y minus by over ax minus bx. All right, so what's the y component of A? Well, that's negative 3. So the y component of A is negative 3. Take away the y component of B, which is 0, all over the x component of A, so that's negative 3. Take away the x component of B, which is 3. So that gives us negative 3 over negative 6, which equals a gradient of a half. Okay. On to the next steepest line, the red one. So again, we've got AY, but this time we're using point C, so CY, all over AX, take away CX. Okay, so what does that give us? So the A component of Y is negative 3, take away the Y component of C, which is 3. The x component of A is negative 3. Take away the x component of C, which is 3. So that gives us negative 6 over negative 6, which gives us a gradient of 1. And so we can see that the gradient of the red line is greater, because it's 1, than the gradient of the yellow line, which is a half. So the bigger the number, the steeper the gradient is what we've said. So let's keep going. Is it true for the blue line? So again, the difference between the y component difference between A and D this time, because we're using a different one, over the difference between the x components of A and D. Okay, so let's have a look. So the A component of Y we know is negative 3. Take away the Y component of D is 7 over the X component of A, which is negative 3, and the X component of D is 2. So that gives us negative 3 take away 7 is negative 10 over negative 3 take away 2 is negative 5. So that gives us 2. Which is what we expected. Blue is steeper than red, so its gradient must be a bigger number. Okay, and 2 is bigger than 1. And then last proof, let's do the green one. So we've now got difference in y's between A and, this time it's E. Why have I put G there? That should be an E. Okay, EY over difference of the x components of A and E. Okay, so A component of Y, negative 3. Take away, what's the Y component? It's 9 this time. The x component of A is negative 3. Take away the x component of E, which is 0. And that gives us negative 3, take away 9 is negative 12. Negative 3, take away 0 is negative 3. And that gives us a gradient of positive 4. And that's what we've got. We've got a line segment that is steeper than all the rest, and its gradient is a bigger number than the rest. They're all positives because they're all sloping up. Okay, so let's have a look if we can find the triangles we've talked about. So for the yellow line, we've got a gradient of a half, which we say means for every 2 we go across, we go up 1. Is that true? For every 2 we go across, we go up 1. So yeah, it is true. The red line, for every 1 we go across, we go up 1. So is that true? Every 1 we go across, we go up 1. So that's true. Blue line, every 1 we go across, we go up 2. So every 1 we go across, I can't get the line colours. Every 1 we go across, we go up 2. So that's right. And for the green, every 1 we go across, we go up 4. So is that true? So for every, let's do it from here. For every 1 we go across, we go up 1, 2, 3, 4. Yeah, I know my lines are a bit off, but there you go. So that is why the greater the number, the steeper the line. If it's positive, it's sloping uphill, and if it's negative, it's sloping downhill. Now that just leaves us 2 special cases to consider. Now here we have 2 special lines. The ones we've considered so far have been diagonal, okay? Whereas these 2 are not. And we talked about these at the very beginning. The red line is horizontal. And the blue line is vertical. Okay, so we know that the gradient formula is dy over dx between 2 points. So let's look first of all at the red line. So let's find 2 points. So let's draw a point here. We'll call that A. And let's draw a point here. And we'll call that B. So as coordinates go, we have A. And A is -4, because the x comes first. And then -3 on the y-axis. And B is +4 and -3 on the y-axis as well. So let's work out the gradient. We know that the formula is dy over dx. So the difference in y's, so we're going to have ay minus by over ax minus bx, the difference between the 2 points for y and x. So ay is -3, take away -3 over -4, take away +4. Okay, so -3 take away -3 is 0, and -4 take away +4 is -8. But we know anything divided by 0 divided by anything is 0. So the gradient of this horizontal line is 0, and that's true for all horizontal lines. And we know this because dy is the difference between the y values. But if you look at the 2 points in a horizontal line, so here, A and B, there is no difference between them on the y-axis because they're on the same line, aren't they? The same level. So with the numerator for this formula, dy dx, is always going to be 0. So horizontal line's gradient is always 0. Okay, right, now let's have a look at the blue line, the vertical line. Okay, so let's pick 2 points here. Let's pick here, we'll call that C. And then let's pick this one here, and we'll call that D. So C is going to be, what's C? So it's 2,8, and D is 2,2. And then we're going for blue. So we know it's dy over dx for C and D. So cy minus dy over cx minus dx. Okay, so cy is 8. Take away, subtract dy, which is 2. All over cx is 2, and dx is 2. So that gives us 8 take away 2 is 6, 2 take away 2 is 0. So anything divided by 0 is undefined. Okay, if you put in a calculator, you get a maths error. Now the reason for that is because the difference in x's, as we get smaller and smaller, okay, approaches 0. So if you think about the lines, we did this when we were looking at the steep line. So we could do it here. Okay, so here is a line. Okay, so that's the difference in y, and that's the difference in x. Okay, but if we keep the y constant, so it's always there, we shorten this, okay, we can see that the line, the hypotenuse, or the diagonal line, is becoming steeper. And the difference here is becoming smaller, isn't it? And as that line gets closer to the horizontal, the difference on the x part becomes even smaller, and it starts to approach 0. Now, as we talk about, in maths, talking about approaching things is A level and beyond maths, but all we need to know, if you divide by 0, divide by any number getting close to 0, you head off towards infinity. Now remember, infinity is not a number, it's a limit or a concept. But vertical lines, we say, have an undefined gradient. okay, no matter where they are. So that's the case for the two special cases. Horizontal lines have a gradient of 0. Vertical lines have a gradient of that's undefined. Diagonal lines always have a gradient. If they're sloping up from left to right, it's positive. If they're sloping down from left to right, it's negative. And the steeper the line, the larger the number. Okay, and that's the basics of gradients and straight lines.